Okay, so good evening, everyone. My name is Tutor Poul Solutions, and I'm from IQ Academy. Okay, so IQ Academy just offers extra lessons for the 4 NS courses, which is math, biology, chemistry, and physics. Okay, so in case you need any help in those 4 courses, you're free to contact myself, which is Tutor Poul. Then we also have Tutor John, who is responsible for physics and biology, and then I'm responsible for mathematics and chemistry. Okay, so this class I've made it to explain some of the concepts that are in your tutorial sheet 1 for those who are taking Math 150, but it's the same even for those who are taking Math 110. It's the same concept. Okay. All right, so the class won't be long. It's just an introductory class, and then if I explain anything and you do not understand, you're free to ask, okay? Just unmute yourself and then you can go on with your question. And then I'll be very happy to assist you. Okay, so I'll go straight into the questions. In the morning, I shared a video in the group. I don't know if you saw it. Okay, so that video is a recording of the introduction to set theory, meaning the terms that you're going to use, the intersection, the union, the complement, all that, okay? So here we're trying to revise those same concepts that are in that video. Okay, so if you watch that video, then it will be very simple for you to comprehend whatever we are going to say here. All right. Okay, so the first question here, they're saying define a set. Okay, I'm pretty much sure nobody here can fail to define a set. Okay, so a set, we say it's a collection of well-defined what? Objects. So meaning those objects that are going to be in that set, they should have something in common. Okay, so very good examples of these sets are the sets of different numbers that you have. So I'm going to give examples of those numbers because you need to know them. Okay, so we are saying a set, it's just a collection, okay, of well-defined objects. Okay, collection of well-defined objects. Well-defined objects. Okay, this is what a set is. And then we can give an example of different sets of numbers that we have. Okay, I'll start with the natural numbers. Okay, so the natural numbers are represented by a capital letter N. Okay, so these are what we call natural numbers. They are also known as counting numbers. Okay, so meaning that what? These are numbers that start from 1, 2, 3, 4, all the way until wherever you are going. Okay, so these are natural numbers, counting numbers. You can use them to count, like 1, 2. Okay, so take note that 0 is not a natural number because you can't use 0 to count. Okay, you can only start from 1 and then all the positive numbers. Okay, as long as it's not a fraction. Okay, it's a whole number. So these are counting numbers. And then we also have what we call as the integers. Okay, so the integers, these are famous numbers that you used to see on the number line. Okay, those numbers on the number line. So even the integers, except expect that you don't have fractions. Okay, so you have negative numbers like this, you have positive numbers like that. Okay, and then you also include 0. So those are what we call as integers. Okay, so this is also an example of a set. Okay, a set of integers. Then this is a set of what? Natural numbers. Okay, so these are some of the examples of the numbers that you're going to come across. Okay, or the number that you're going to be dealing with. So it's very important to know. Yeah. And then in the other video, I mentioned all the numbers, I guess, and I defined them. So someone at their mic can mute it. Please mute your mic or giving us a feedback. Or let me mute. Okay, that's good. Okay, so this is these are some of the examples of sets of numbers. I've just given 2, okay, natural numbers, which are counting numbers. And then I've also given integers, which are those numbers on the number line, okay, provided that they're not fractions, okay? So that it can be negative or they can be positive, and you include the 0 as well. Those are what? Integers. Okay, so that's what a set is. And then if there are any questions, you're free to ask before we go to number 2. Okay, no question means I'll proceed. So the other question now here, they're saying define a subset of a set, okay? And then the question continues to say, what is meant by a proper what? Subset, okay? So a subset and a proper subset. A proper subset is a type of subset that we have, okay? So the one that is usually called the subset is also called the improper subset, okay? And then we have the other one now, which we know as a proper subset. So what's the difference between these two? So we know that a subset, okay, we know that if A is a subset of B, okay, if A is a subset of this B here, then what does that mean? Okay, it means that okay, so I was saying what? I was saying if A is a subset of B, okay, it means that every element in this set A is also found in this set what? B. Okay, so that is what is meant by a subset. Okay, so you can say a subset of a set B, okay, is another set A such that every element of A is also an element of what? Of B. So I sent the written solutions last night. So I hope you went through those solutions, okay? So every element of this guy will be in this guy. Then we can say that A is a subset. So example, if I have A as the set that contains maybe 1 and 2, okay? And then I also have B here as the set that contains 1, 2, let me say 3. So we can see that all the elements in this A are contained in this set B there. So we say that A, okay, is a subset of what? Of B. Okay, so now what's the difference between the improper and the proper subset? Okay, so the improper subset is a subset such that every element of this A, okay, is also an element of this. Like every element of this guy here is an element of that guy. Then we say that it is a proper one. Okay, the way it is here, we say this one here is just a subset, or it's an improper subset, because I can see that in this set A, okay, not all the elements of this set B are there here. So let's say, for example, I had another set D here, okay, and this set D contained 1, 2, 3 as well. So you can see that this set D here contains all the elements of what? Set B. Okay, so we would say that D is a subset or an improper subset of what? Of B. Why? Because every element of this D here is also in the B there. Okay, but if some of the elements in this B are not in another set, for example, this A here, we can see that A only has 1 and 2, but this B has 1, 2, 3. So it means this 3 here is not in this set. So we say that this set here, A, it's a proper subset of what? Of B. Because some of the elements of B are not contained in what? In A. So that's the difference between the proper subset and the improper subset. Okay? So I don't know if there are any questions there. Okay, I hope that is clear. Okay, and then let's look at the other questions. They're saying define a power set. Okay, define a power set. So a power set is just a set A, okay? That is a set of all the subsets of A, including the empty set and the set itself. Okay, so let me give an example. So if I have this set A, okay, that has these two elements, 1 and 2. So from this set A, we can get subsets, okay? We can get subsets from this set A, okay? So we can get the subset, the one that contains 1 only. We can also get the subset that contains 2 only, okay? Or we can get the set itself is also a subset of itself, okay? Or we can get the what? The empty set. So this set here, set A, it has how many subsets? It has 4 subsets. So the power set now is the set of all these subsets of this A. Okay, so you see the power set of A. Okay, so this is the notation that you use, power set of A, P of A. It means power set of A. So the power set of A will be a set that will contain all the subsets of this what? A. So here inside you're going to write 1 as your first element, and then 2 as the other element, okay? The set itself, and then you're also going to put the empty set like that, okay? So this one here, what we have drawn here, what we have written here, is what we call as the power set of A, okay? So a power set is just simply the set that contains all the subsets of that given set here, okay? So we had this set, we get all the subsets from this set here, we list them here, and then if we combine these all sets here and put them together, we are coming up with what we are calling as what? A power set. That's a power set, okay? All right, so I hope that is clear. Okay, otherwise I'll move to question, well, I think it's question 4. Okay, so today is just an introduction. I won't do much. So question 4 here, we've been given 2 sets. So here now we use the set operation, the union. I know you know the intersection, okay? But I'm not sure if you know the difference here, okay? But we are going to deal with that. So we are saying if A is the set 1, 2, 3, 4, 5, and then B is the set 2, 4, 6, 8, 10, okay? Find the union, A union B. And then we are also told to find A intersection B. And then here we are told to find A minus B. This should be a capital A like that, A minus B. And then here we are told to find B minus A, okay? So let's get these 2 sets, and then we try to find the union, the intersection, and their differences, okay? So we have the set A here, which contains 1, 2, 3, 4, and 5. Okay, so these are the elements of set A. And then I have set B here, which contains 2, 4, 6, 8, and 10 as its elements. Okay, so the first question we're asked to find A union B. So what is A union B? What is the union of set? Okay, so the union of 2 sets is simply combining the terms of this set A and this set A without repeating any of the elements that appear in both these sets. Okay, so we see that I have a 2 here that is appearing in this set. Okay, it's also appearing in this set. And I also have a 4, which is appearing in that set. Okay, so in our union, we are going to write these elements, okay, from the smallest to the largest, but making sure that we do not repeat any number that is in both this A and B. Okay, so we are going to say A union B will just contain 1, 2, 3, 4, 5, and then we come here. The 2, we've already written it, so we don't write it again. Okay, 4, we've already written it, so we don't write it again. And then we continue 6, 8, and 10. Okay, so this set here that I've written out here will be our A union what? B. Okay, so make sure that when you are taking the union, you don't write one element twice if it's appearing in both the sets. Okay, and then another set we are taught to find was A intersection B. So how do you find this A intersection B? Okay, so A intersection B is talking about elements that are common to both this set A and this set what? B. So we are just going to look for elements that are both in set A and in set B. So we can see these 2, these 4, even here, these 2 and these 4. So it means our intersection will just contain 2 and 4. Okay, so this will be our what? Our intersection. Okay, any questions there? Okay, if there are no questions, I'm going to find the difference now. Okay, so let's now find A minus B. Okay, A minus B. So what is the set difference there and what does it mean? Okay, or if they tell you to find B minus A, what does it mean? Okay. Okay, so we start with the A minus B. Okay, so A minus B, what does it mean? Okay, so if you've been given two sets, like in this case, we have A and B, okay, and then you are told to find A minus B. What does that mean? Okay, anyone who knows what it means, anyone who can try. What does A minus B mean? Anyone? Okay, so the set difference simply means that A minus B, it means that this set here contains, okay, contains elements in A, okay, but not in B. That's what the A minus B means, okay? We are getting all the elements that are in this A, but they should not be what? In B. So when you look at this set here, and then you look at this set here, okay? If I get this element, this set A, okay, let me write this set A, okay? And then 4, and then 5. This is my set A. So in this set A, okay, I'm saying A minus B. So in this set A, I'm going to remove all the elements that I can see in this set B. Okay, that's what it means to be A minus B. So I'm going to use red here to cancel out the elements that I can see both in this set and in this set. Okay? So the elements that are in B and are also in this A are 4. I can cancel out the 4. Okay, I can also cancel out the 2. So the elements, okay, that will be in A minus B will just be these elements here, 1, 3, and what? 5. These are the elements that are going to be what? In A minus B. Okay, so A minus B simply means all the elements that are in A, but they should not be in what? So we wrote out all the elements that are in A first, okay, and then we cancel out those we can see that are also contained in. Okay, so our A minus B will be 1, 3, and the 5 there. Okay. Okay, so let me write it here. So we had 1, 3, and 5. Okay, and then B minus A, okay, we're going to use the same approach. So it means here now, we are getting all the elements that are in B, but they are not in what? In A. Okay, so we can use that approach that I used at first. I'm going to write out all the elements that are in B here. So I'll write 2, 4, 6, 8, and then 10. Okay, and then from these elements, I'm going to remove all the elements that I can see in this set B that are also in what? In set A. So I can see 4 and 2. So you cancel out the 4 and 2. It means your B minus A will just contain what? 6, 8, and 10. Okay. So this is our B minus what? A, and then this is our what? A minus B. Okay, so any questions there on the set difference? Any questions, guys? Okay, awesome. No questions. All right, so I'll go to question 5 now. Okay, so what has question 5 for us? Okay, so question 5 now, we are looking at, okay, so question 5, we are looking at which of the following sets are empty, okay? Okay, so we are saying which of the following sets are empty. Okay, so these sets here that you can see, this one, this one, this one, have been represented in what we call as the set builder notation. Okay, so that set builder notation is more like a formula that gives you the element of that set. Okay? That's what the set builder notation is. Okay, I will share the video at the end of the class where I was talking about the set builder notation. Okay, so all these here that we've been given here are formulas that will determine the members of this set here. So this set is read as, okay, this is a set of all x's such that x is a real number, okay, and x plus 6 is equals to x plus 6 is equals to 6. Okay, so it means for you to find the elements of this set, you just get this equation here and solve it. Okay, so the answer to this equation will be the elements that will be what in this set here. Okay, so let's solve it. So the first one there we have number 1. Okay, we have this set, the set of all x's such that x is a real number. Okay, x is a real number, and then x plus 6 is equals to what? 6. So this formula here that we've been given there, it will be the one that will help us to determine, okay, the elements that are going to be in this set. So how do we find the elements that are going to be in this set? We just simply solve the equation that we have there. So we're going to say x plus 6 is equals to what? 6. And then this will be x is equals to 6. We get this x, it goes to the other side. Okay, it becomes minus 6. So it means x will just be equals to what? 0. So it means this set here is a set that contains only what? 0. So is this set an empty set or it's not an empty set? Anyone to answer? Anyone? Is this an empty set or it's not an empty set? Come on, guys. Is this an empty set or it's not an empty set? Okay, it's not an empty set, but because it contains an element, and that element is what? Is 0. Okay, that's why when you're dealing with notation, okay, and then they tell you to write the symbol of an empty set, you can either use this, okay, this is an empty set, or you can use a circle that is cancelled like that. This is an empty set. But if you write this and then you put 0 there and then you put like that, this here does not mean an empty set. Okay, this one contains the element 0, so it's not an empty set. Okay? So this one here, the first one, not an empty set. Why? Because when we solve the set builder notation here, it gives us the answer, which is what? 0 there. Okay, let's look at the second one. So let's determine if this is an empty set or it's not. So we have this set, a set of all x's such that x, okay, is an integer. Okay. Oh, we are saying this is the set of all the x's such that x is an integer and x, okay, squared plus 1 is equals to what? 0. So this formula here that you can see here is the one that will give us the elements of what? Of these sets if we have any. Okay? So you get this guy here, and then you solve for x. Okay? So if we get this guy, x squared plus 1 is equals to 0. Okay, we want to solve for x. So we are going to say x squared, and then we take this one to the other side like that. So this will become minus 1. Okay. Okay, so we want the value of x only. So what are we going to do? We are going to do the square root this side. Even here, we're going to do the square root. So it means that your x will be equals to the what? The square root of what? Minus 1. But the square root of minus 1 here, okay, is not an integer. It's not a real integer. It's not a real number, okay? The square root of minus 1, if you punch this on your calculator, you see that you have error, okay? You have scientific error. Why? Because the square root of minus 1 is not a real number. This is a complex number, okay? So it means this equation here has no solution, Okay, when we are in the what? The integers. Okay, but if we are the complex number here, this will be a solution. But here we have the integers, we have real integers. Okay, so it means the x squared plus 1 is equals to 0 does not have a solution. So what does that mean to our set? Is it empty or it has something? It means the set is empty. Because why? This guy here does not have a solution. So you can write no real integer solution. Okay, no real integer solution. What does that mean? It means this set is what? Empty. Because its formula does not give any answers when you're considering the set of what? Real integers. Okay, so the second one there you can classify as an empty set. Okay, that's an empty set because we can't find real values there. Okay, and then number 3, let's categorize this set as empty or non-empty. So on number 3, we have this set. Okay, we have the set of all x's such that, okay, x is a real integer. Okay, and then x squared minus 4 is equals to 0. Okay, so how are we going to find the members of this set? We are going to get this formula here and equate it to 0 and then solve for x. Okay, so x squared minus 4 is equals to what? 0. So what would this give us? It will give us x squared. Okay, x squared is equals to 4. And then we take the square root of both sides. Even here, we take the square root. Okay, so here the square root and this square are going to cancel. So we are going to remain with x is equals to, and then what is the square root of this 4 here? Okay, since we are the ones who have introduced this square root here, here we're going to say plus or minus. Okay, it can either give you a positive value or a minus value. So here we're going to say plus or minus what? 2. So it means this equation here has 2 answers. Okay, it has x is equals to 2, and then it also has x is equals to what? Minus 2. So this one here is not an empty set. Why? Because it's a set that contains 2, or should I say minus 2 and 2. Okay, so this one here is non-empty. It's not an empty set. Non-empty. Okay, so any questions there, guys?
So on this same question, why don't you just write in a positive 2 instead of a plus or minus 2?
Okay, so if you heard me correct, I said when you introduce this square root here, where is it? Let me use here. Okay, so here, remember we had, let me rub it like this, then I show it again. Okay, so we have this equation here, right? We want to solve this equation. So we're going to say x squared is equals to what? 4. And then we're going to introduce a square root like that. Even this side, we're going to introduce a square root. So by the fact that we are the ones who are introducing this square root like that, okay, this square root and this square root are going to cancel. So we're going to remain with x is equals to, but this side, because it's us who have introduced this square root here, we're going to have 2 answers. We're going to have one which is positive, and then the other one which is negative, and then 2. Okay, so you don't get one answer from the square root of 4. The square root of 4 can be minus 2 or it can be positive 2. Why? Because if you multiply minus 2 multiplied by minus 2, okay, you get what? 4. If you multiply 2 multiplied by 2, you get what? 4. So the square root, it's always a negative and a positive. Okay, because when you're multiplying them, you still get a positive now. No wonder here we have 2 answers like that. You don't consider only the positive part. Okay, you also consider the what? The negative part. Okay, the one who asked the question, is that okay?
Yes, it's now okay.
All right, so that's how you deal with those. And then let's look at the other questions. I think it's number 6. Okay, so here they're saying define the cardinality of a set. Okay, I'm pretty sure you know this, but it's just the term that is new. Okay, so the cardinality is just the number of elements in the set. We used to write like what, like a small letter n, something like that, and then we say a, and then we say maybe 5. Okay, so the cardinality is just the number of elements in a set. Okay, so if I have this set, let me say it's set A is equals to 1, 2, 3, 4. Okay, if this is my set. So the cardinality of this, I'm going to write NA, and then I'm just going to count these elements like that. That's the cardinality of the set. Okay, so cardinality, how many elements do we have here? 4. Okay, so very simple. And then we can look at question 7. So question 7 here, it's saying if a set A has n elements, okay, find the number of elements of the power set of A. Okay, so if you remember that formula that you used to use to find the number of subsets, okay, what was that formula? It was 2 to the power n. Okay, so if given any set, you can just count the elements that it has. That's what this n represents. Okay, and then those will be the number of subsets that it has. Okay, so for example, this one here has 4 elements. So how many subsets will it have? Okay, we are going to put 2 to the power 4. So 2 to the power 4 is what? 16. So it means this set here has 16 what? Subsets. Okay? So now here they're just passing it because you are at the university level. They are saying power of the set. Okay, I earlier defined what the power of a set is, right? It's just a set that contains all the subsets. Okay, so they're saying here if a set A has n elements, find the number of elements of the power set of A. Okay, so the number of elements will just be 2 to the power what? N. So number of elements in the power set. Okay, number of elements will just be equals to what? 2 to the power n. So this is the formula that you should always use when you're finding how many subsets a set has. Okay, just do 2 to the power n, that's all. And then this n, just the number of elements in that set. Okay. So, okay, so after I've said this now, I have a very nice question. Okay, if I have an empty set like this, okay, how many, if I have an empty set like this, how many subsets will this have? Hello, how many subsets will an empty set have?
Since it has nothing in it, so we can't count the subsets in it.
We can't count the what?
Subsets in it.
Okay, so yeah, so they like bringing that question.
But for me, I can say it has one subset, because when you put 0 where there is n numberless to the power 0 is 1.
Excellent. Okay. So yes, so any set that you can find on this earth, okay, has a subset, including the empty set itself. Okay, it has a subset. So this one here does not have any elements. Okay, so it means the n here will be 0. Then how do you find the number of subsets? You do 2 to the power n, but the n here is what? Is 0. So 2 to the power 0 will just be what? 1. So the empty set has 1 subset. Okay, so take note of that. It can be a question to trick you. It can come. Okay, all right, and then let's look at question 8. Okay, so what does question 8 state? Okay, so question 8, we have been given 2 sets in form of set builder notation. Okay, so we first have to interpret the set builder notation. Okay, find the elements that are in those sets. Okay, and then go on and find their intersection. Okay, so here we've been told that find the intersection of the following sets. Okay, so the first set is this, and then the other set is this. So these sets have been given in set builder notation form. So first we have to interpret these sets, find what elements are in this set, and then again find what elements are in this set, okay? And then now look at the common elements in both these sets. So that's what we are going to do. Okay, so we're going to say let this be set A, and then this other one here, let it be set what? B. Then let's interpret it. So let me go on my board here. Okay, so I have my set A in set builder notation. Okay, it's a set of all the x's such that x squared minus 1 is equals to what? 0. So we have to use this formula here to find out what elements are in this set A. So we are going to say what? We are going to get that x squared minus 1 is equals to 0, and then solve for x. So we're going to say x squared minus 1. Okay, x squared minus 1 is equals to 0. And then we have x squared is equals to what? 1. So that case again has come that I was explaining. So you square root both sides, okay? But this here, because you've introduced this square root, you're going to say plus or minus. So it means your x will just be equals to what? Plus 1, or it will be equals to what? Minus 1. So it means this set A here contains these two elements, okay? So set A contains minus 1 and 1. Okay, and then let's find the other set, which we said was B. Okay, so set B was given as a set of all x's, okay, such that x squared plus 2x plus 1 is equals to what? 0. So these are quadratic functions, right? Quadratic equations. Okay, so you have to know how to solve the quadratic equation. You find the factor, the sum, and the product. Okay, so the product will be what? The product will be 1 multiplied by 1, so the product will be 1. And then we have the sum, which is 2, this middle term here. And then we have the factors. Okay, so what two numbers can we multiply? Get 1. And then if we add them, we are getting 2. Okay, so those numbers are just simply 1 and 1. If you multiply this, you get 1. If you add them, you get what? 2. Okay, so you see the magic there. So let's factorize this guy using the factorization method. Okay, so x squared, and then this 2x here, we're going to separate it into its two factors here. So we have plus x plus x. Okay, we have not changed anything. We just separated this guy here into its factors. Okay, and then we are saying plus 1 is equals to what? 0. And then we are going to group these guys here. Okay, later on I'm going to show you a shortcut now to solve quadratic, but let me go the traditional way. Okay, so we have x squared and x in one bracket, and then in the other one we have x plus 1. So in this bracket here, we can see that the x is common. Okay, what is remaining here is just the x, and then what is remaining here will just be plus 1. And then in the other bracket, what is common here is just a plus 1. And then we'll remain with our x plus 1 is equals to what? 0. So now our factors will be this guy and these two that are outside, okay? Because these are common here. So we are going to have x plus 1, and then we are also going to have x plus 1 is equals to what? 0. So if I equate any of these to 0, I'm going to get my x is just what? Minus 1. So it means this set B here, okay? This set B here, it's just a set that contains one element, which is what? Minus 1. Okay, so now after finding the elements of A and the elements of B, we can now find their intersection. Okay, so the intersection of A, intersection B, will just be what? Minus 1. Because you can see that minus 1 is here and it's also there. So this will be our what? Our intersection. Okay, so that's how you do it. So know how to interpret the set builder notation, find the elements that are in those sets, and then you can now find the what? The intersections at the end. Okay. All right, so let's look at the other question, which is question what? This is question 9. Okay. All right, so question 9 here now we have 3 sets. They're saying A, B, and C. B sets such that A is this, okay, B is that, and then C is that. Okay, so you have to know the sets of numbers that you have. Okay, So this Z here, I said it represents what? The integers. And the integers are those numbers on the number line, okay, including the 0 itself, but excluding any fraction. Okay, we are not dealing with any fraction. We're just going from -3 to -2 to -1 to 0 to 1, 2, 3, 4 until forever. Okay, we are okay, sorry for that. Network kicked me out of the meeting. Let me continue. Okay, so we were on Elise, your camera is on. We can see you. Okay, so turn off your camera. So we're on question 9 here, and then we are saying what? This is the set A, this is the set B, and this is the set C. And these sets have been given in set builder notation form. Okay, so we need to know how to interpret this set builder notation form, and we also have to know what this statement here, X is a member of this, what it means. Okay, so here we have our X's are all what? Integers. Okay, they are all integers. So let's interpret these guys, and then we'll be able to find these. We can also find whatever is. Okay, so I'll start with A, B, and then C. So let's interpret the set A. Okay, so the set A has been given like this. Let me use white here. Okay, so this is the set A here. So we have been told that in the set A is a set of all x's such that the x is an integer, okay? And then the x is between -3 and what? And 3, okay? So this is the set A here. So it means we can list this set, okay? If we list this set, we are just going to start from -3 all the way to 3. All the integers that are in between here, we are going to list them as members of set A. So we're going to say -3, -2, -1, 0, 1, 2, 3. Okay, so these are the members that are in what? Set A. And then set B, okay, it was given x is an integer, okay, such that x is between 0 and 5. Okay, so x is between what? 0 and 5. So these symbols here mean x ranges from 0 all the way up. So we can list the integers that are between 0 and 5. It's just 0, 1, 2, 3, 4, and then 5. Okay, so these are the integers that are between 0 and what? And 5. And then we also have C, which was given as x is an integer, okay, such that, okay, x is between 2 and 6. So this is what we've been given here. X is between 2 and 6. So this will be equals to, so let's list all the integers between 2 and 6. So we're going to say 2, 3, 4, 5, and then 6. Okay, so you can see that from the set builder notation that we have here, we're able to list down the elements that are in those sets. Okay, why are we able to list them? Because we are dealing with a very good set of numbers here, which are integers. Okay, if it was real numbers, then we wouldn't mind. I mean, wouldn't manage to list all the elements like that. Okay, because if you're dealing with real numbers, you're including all the fractions. So meaning 1 point what, 2 point what will be in this set. So we can't list all of it. We just use intervals for them. But here, because we are dealing with the what? The integers, we can easily list them out. Okay, and then we can find the questions now that they wanted us to find. Okay, so the first one, they're saying find A union B. Okay, so we're finding A union B, and then we're finding A intersection B, and then we're finding A minus what? C. So let's do that. Okay, so A intersection B. I'll write it here. I mean A union B at first. So A union B, what will it contain? It will contain all the elements that are in B and all the elements that are in A without repeating any element. Okay, so the lowest element I can see is -3. So I'll write -3, -2, -1. Okay, and then 0 is both in this set and this set, but I'm just going to write it once. Even the 1, it is in both ones. 2, it is in both ones. 3, it is in both ones. And then 4, and then the 5. Okay, so this set here will be my what? A union B. Okay, and then what is our A intersection B? A intersection B. So A intersection B, we're looking for those terms that are common both these sets. Okay, so I can see that those that are common start from 0 all the way up to 3. Okay, I can see 0, 1, 2, 3, giving me 0, 1, 2. So that the ones that are common. So those will be in the intersection. So 0, 1, 2, and then 3. So this is our A intersection B. Okay, and then we also have A minus C. So what did I say about the set different? I said we are getting all the elements in A, and then we are removing all the elements that are also in what? In C. Okay, so a simple way to find it is just first list down all the elements in A. Okay, so in A, what elements did we have? We had, okay, where was this? We had these elements from -3 to 3. So let's list them. Okay, we are listing all the elements in A first. Okay, 0, and then 1, 2, 3. Okay, and then after listing all these elements in set A, let's remove all the elements that are in set A, but they are also in what? In set C. Okay, so in set C here, let me put it like I can see a 2 is in set E, and it's also in what? Set A. I can see a 3 that is also in set what? A. Okay, so I'm going to remove these 2 elements from set A to find my set A minus what? Minus C. Okay, so from this here, I'm going to remove these 2 elements, the 2 and the what? The 3. So it means my A minus C will just be the set -3, -2, -1, 0. Okay, 0, and then 1. Okay, so only these elements here are the ones that are going to be in what? A minus C. Okay, so any questions there, guys? Any questions there?
I'm just behind on this one. So since now this question have been given in this way, so does it mean that we are going to remove the elements that are found in C from A, and then those that are going to remain in A are the element we are going to write, or what does it mean?
Oh, the one was asking a question. I didn't get you clear. Speak a little bit louder.
I was saying, this question of involved A minus C, does it mean that we should remove the elements that are in set A, or we should remove the elements that are in set C from A, and then those elements that are going to remain in set A are the element we are going to write, or what does this statement mean, A minus C?
Yes, okay. So you're getting, you are removing all the elements that are in set A. I mean, all the elements that are in set C, but they are also appearing in A. They are elements that you are removing from A. Okay, so this is A minus C, meaning you are removing all the elements that are appearing in C, but they are also in what? In A. So here we did it like, we wrote first the elements that were in A, right? Okay, and then we looked at the set C. What elements are in C, but they are also in A? We found that the 2 and the 3, they were in C. Okay, so we have to remove those elements from A. No wonder here, you just canceled them like that, and then you wrote the ones that remained here.
It's clear now.
Have you gotten it? Hello, the one who was asking, have you gotten it?
I'm clear, yes, I'm clear, sir. No problem. You have explained well.
All right. Okay, so I think now we can solve question 10. Okay, I just said I'm going to go up to question 10. So let's solve question 10 here. So question 10, what does it have? Okay, so where's question 10? Oh, we haven't done, we're not done with question 9. There's this question. Okay, so this is a very important law when you're dealing with the sets. Well, what we call as the De Morgan's laws. Okay, so we have two of them. The first type is this one that we've been given here. Okay, then we also have another type that I'll show you. So here they're saying verify the De Morgan's laws. Okay, by showing that A union B complement, okay, is equals to A complement intersection B complement. Okay. Then they have also given us the universal set from -5 to 6 here. Okay, so let's do that. Okay, someone was calling me, sorry. It's saving my network. Okay, but let's continue. So we want to prove these De Morgan's laws. So what are we going to do? Okay. So we have A union B, okay, and then we have a complement. This should be equals to A complement intersection B complement. Okay, so someone's mic is unmute. I can hear some background. So mute. Okay, that's big. So we want to prove that whatever we have on this side is equal to whatever we have that side. Okay, so what are we going to do? We have been given the union set there. Okay, we've been given the union set as the set that starts from -5 all the way up to 6. So if I list it, I have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, okay, 6. So this is the universal set here. Okay, so what does this complement actually mean? Okay, so the complement simply means that the elements that are not in this set here. So I'll give a simple example first here. Okay, so if this is my universal set, right? And then let's say, for example, I had a set A where I had -5, -3, and -2. And then you are told to find the A complement. Okay, so the A complement will be all those elements that are in the universal set, but they are not in this set A. Okay, so meaning 5, 4, 1, all these elements will be in A complement. Okay, so elements that are not in that set, but they are in the universal set. That's what we mean by what? Complement of a set. Okay, so here now, we want to prove that whatever we have on the left-hand side, okay, which is A union B complement, is equals to A complement intersection B complement. Okay, so let's first find the A union B. The A union B, we already found it. Okay, we already found it on top there. It was what? What was our A union B? Here we found it. Okay, so this was our A union B. So I'm going to write that. Okay, starting from -3 all the way up to 5. So we had -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, so this one here was our A union B. Okay, so now we want to find our A union B complement, meaning all those elements that are not in A union B, but they are in the what? The universal set. So those are the elements that we want to list out. So I'll say A union B complement, okay, is equals to, and then I'm going to write all the elements that I can see in this union, but they are not here. Okay, so we can see that starting from here, all these elements up to